Okay, so this says some potential dangers when solving equations. Remember, if we use the associative, the commutative, or the distributive property, it does not change the problem. Now, what I will guarantee you is you will see problems like this where you have to explain what you are doing using mathematical language. So make sure that you pay attention because you are going to have problems where you have to explain mathematical language. So, where's my keyboard? There it is. So in this problem, describe the property used to convert the equation from one line to the next. So what did we do here? Well, we got rid of this parentheses by multiplying. So this was the distributive property. Okay? So now I've combined, what did I do? Well, I added x squared to the opposite side. So what property is that? That's the additive inverse. Okay? And my notes actually don't say that. It just said added x squared to both sides of the equation. And I hate that. Why is it that the stuff that we're using, I'm better than them? This is the additive inverse. Because what did we do? We added x squared to both sides. This is absolutely the additive inverse property. Use the correct terminology, Engage New York. This, okay. So now we have x plus 2x equals 8x minus 24. So that's good. Then we got 3x. So what did we do? Well, we combined like terms. Okay, there is no other better way for that. We simplified. We combined like terms. Over here, what did we do? We used the additive inverse of 24. Additive inverse. And then I'm going to put in parentheses, I'm going to put 24. And again, our book says added 24 to both sides of the equation. Yeah, again, you're using the additive inverse. You stupid book. Last but not least, we used the additive inverse. We got rid of the 3x from one side. But which one did we use? Well, this time we used negative 3x. Why negative? Because we had to subtract 3x from both sides, or add a negative. So I'm telling you what we're doing. So this is a plus 24, this is a minus 3x. Why are we sure that the initial equation and the final equation have the same solution set? Well, what did we use? We used the distributive property and the additive inverse. We combined like terms. None of those change the problem. It keeps it balanced. As long as we're keeping it balanced, it will stay equivalent. Mr. H, I didn't do so well on that one. Okay, well, thanks a little bit. Let's do another one. What is the common solution set to these equations? Oh, well, divide by 5. X equals 4. All you have to do is solve it. So the common solution set is 4. It would work for both of them. How can I be sure? Well, we brought it down to a simpler equation for ourselves. Okay, solve the equation for x. Each step, describe the operation used. A lot of different opportunities to do this. So I'm going to put a line out here, and I'm going to solve. So here for me, I'm going to distribute 3x minus 8 stays. That leaves me negative 3x plus 3 in this bracket equals x plus 19. And I guess it would help if I put the line at the right place. What did I do? I used the distributive property. Okay. Now what? Well, we've got a lot of options. We've got a lot of options. I'm going to write this, 3x minus . Okay, so there's two different things that I should really be writing down, but only one key. So somehow I got 11. How did I get 11? Well, we combined like terms. What should I have really done? Well, I should have put the 3 next to the 8. So I combined like terms using the commutative property. Because I wanted to put those together. Do you need to put the commutative? No, because combining like terms for us means we can combine like terms anywhere. Okay, so now What did I do? Well, I distributed. Okay? Then I would put combine like terms. And I'm going to run out of room. Then I'm going to say, okay, subtract x, and then I'm going to get 5x minus 11 equals 19. What did I do? I did the additive inverse. And then I'm going to put in parentheses a negative x. Then I'm going to have 5x equals 30. And there I'm going to put additive inverse, and I'm going to put positive 11 because I'm going to add 11. And then I'm going to divide by 5. Now that leaves me x equals 6. Well, what did I do to get to x equals 6? Don't put divide by 5. Put multiplicative inverse. And then what are we going to put in parentheses? Well, we're going to put 1/5. That's the same as dividing by 5. Questions? Okay? It does take a lot of work. It takes time for you to learn exactly what you're doing. I hope that you see every time that we've solved an equation, especially during that prep module, I kept asking you, what operation, what property are we doing? It is imperative to know exactly what the mathematical language is. So, I would like you to do this next one on your own. So the next one is number 3. You're going to pause it once you have it. I'd like you to try 3, let's go 3A. So you're just doing 3A. Go ahead, pause me, do that. And then I'm going to come over here and I'm going to say, okay, hey, welcome back. And I'm going to show you what they have. Okay, hopefully you can see that. There's the answer for 3A. So I agree with the distributive property. Collected like terms, I'm going to say combine, same thing. Distributive, great. Combine like terms, where it says subtract x from both sides, that's the additive inverse. And I'd put negative x. Added 3 to both sides, I'd put additive inverse, and then I'd put 3 in parentheses. Divided both by sides by 5, that's not a property. The property is the multiplicative inverse of 1/5. Okay, so knowing language and being able to speak it, I promise, will make you seem smarter than you actually are. It's imperative to know these properties. You will not be done hearing every single one of these. Okay? That's the lesson. Remember, the key to this is, just like the last lesson, associative, commutative, distributive, additive inverse, multiplicative inverse. Does not change the integrity of the problem because we're doing it to both sides, or we're just simplifying one side. We're not actually changing the problem. If I multiplied this side by 5 but not this side, it's out of balance. If I add 100 pounds to this side but not this side, it's out of balance. If I distribute to this side, well, it's already asking us to multiply. That doesn't change anything. So we don't need to do it to both sides. Just be careful in knowing what can we do to only one side to keep it in balance. Have a great day.